So we want to look at the characteristics or the properties of straight lines in a coordinate plane. And when we look at any line, any two lines, we can differentiate any two lines based on two characteristics. Okay, so if we take a look at this line here, okay, which maybe I'll highlight in yellow. So this yellow line that I've highlighted, and if I compare it to the blue line that I've highlighted, those two lines are different. Okay, we can clearly tell that those are two different lines. And one of the characteristics we could use is that they have different slopes, okay, or different angles. So one of the two characteristics that allow us to differentiate two lines is going to be the slope, okay, or I'm going to also write here the angle. Okay, the slope ratio is different for those two lines. They're going in different directions and at different angles. So that's one thing that allows us to differentiate two lines. The other characteristic that allows us to differentiate two lines is going to be this. So when we look at these two lines, we cannot differentiate these two lines by slope because they have the same angle. Okay, so the slope is not different between those two lines. But what's different between these two lines, this blue line and the yellow line, what differentiates these two lines are they're in two different spots. So if I slid them into the same spot, they would represent the same line. However, they are in two different positions, so we're going to differentiate that line by position. Okay. Now, these two lines here share one position, so we need to have both of these to differentiate any two lines in space. Now, this position, we're going to use a convenient position here. And a useful position to differentiate these two lines is we're going to look at the vertical positioning of them. And when we look at the vertical positioning, it's kind of nice to just reference it along that dark line there, the axes, okay, where it crosses the y-axis. And we're going to start calling this something specific. We're going to call this the y-intercept. Now, this is not the only place we can reference the position of this line. In fact, we can reference the position of this line based on any one of these coordinates, but this just happens to be a convenient one. And it's useful when we start doing problems as well, because this is when x is equal to 0, so it represents a starting position. So then when we look at any two lines in space, we can see that this line has different slope than this line, so we can tell that they're different. Although they share the same position here, right, they are different. Same with this line compared to this line, they have different slopes. But even when we have the same slope, we can differentiate two lines of the same slope based on their positioning. So as long as we have these two characteristics, we can differentiate one line from another, and they give us a unique line. So what we've been alluding to before, in a lot of the lessons before, we've been kind of alluding to the fact that there's these two properties, angle and position, or slope and position. And these show up on a graph. We can clearly see slope and positioning on graph. They also show up in a table. They also show up in word relationships. For example, the positioning, we often use the initial position, and the slope, from the last lesson, we knew that the slope represents some rate in the problem, in a word problem. But we also know that these show up in the equation form. And this is what we're going to start focusing on. We want to know how to come up with the y equals equation based on slope and positioning. And we want to see where those two elements show up in an equation form. So what I want you to do first is I would like you to do the worksheet, the linear relations y-intercept. Go through that, and I want you to try to find if there's a relationship between the y-intercept, okay, and the numerical constant in the equations that you were given in that. Okay, so I want you to go to that next sheet and then come back to this one.